Welcome back. So we can now start the second session. We have three speakers in this session, and it's my pleasure to introduce Professor Pekka Abrahamsson, who is Professor of Information Systems and Software Engineering at University of Jyväskylä in Finland. And the title of his talk is From Principles to Action, a method for ethically aligned AI design and implementation. Pekka, please take the floor.
Thank you for the kind introduction. It is my honor to be here and to present quite practical presentation on how actually to deal with the AI ethics in when you develop AI-based systems. And before I go to the actual, let's say, the detailed topic, I will just briefly highlight my background. And I started in the 1990s as a software developer. I was developing software for Nokia Corporation, and many of you remember Nokia because of the mobile phones that used to exist, but they don't exist anymore. And as a software developer, I became quite worried about the quality of our software. We didn't use the state-of-the-art methods, and the company made me a quality manager because I was so worried about the quality. Well, that made me even more worry. How are we doing? So I ended up having my PhD in the topic in 2002. And since then, I have taken my professional academic career. And in my early, let's say, when I was young, I was quite sportive. I was an athlete. I was in an Olympic team swimming. I never made it to the Olympics. I was in the B team, so it would have required everybody from the A team to die. So they didn't. I didn't make it. And another interesting fact is that I actually played American football in Finland, and I got drafted in Nebraska to play college football. So back in the early 90s. But so I have been working with emerging technologies from ever since, and trying to be one of the first ones with coming up, or at least one of those who are exploring new topics. And this year we published as the first in the world the AI ethics method for AI and software development. And this is the actual, let's say, the details of today. And the reason why we are focusing is it's no surprise to everyone that the past 10 years has been a huge success on the how the AI has penetrated to every part of the society, but many mistakes have been made. And the public has grown concerned whether we can trust the systems that are powered by the AI, and the companies and public organizations need to have ways to deal with these concerns. Now, in software systems development, the way to deal with that is to actually have something tangible, something to work on. And if we look at what we have out in the market, in the past few years, we have seen a huge number of different, let's say, guidelines or principles or published. They're quite high level, and they come from wide different sources. So how that actually works in practice is what comes to my mind. But that's what you have now, and they are being published by public organizations, even governments, and maybe even nations, like together at the UN level, not sure about that. But when you look at the corporate side and you see what's happening in practice, if you take a look at the anecdotal evidence, you see that it's quite a bit of a mess there. So you have a wide range of discussion. One angle, of course, being that whether we should be actually focusing on making ethical AI systems, ethical artificial intelligence machines, rather than trying to take these into account, but let the machine take care of it. Who should decide in the company? Should it be a board level issue? Well, if it's made, we have learned that Google scrapped its AI ethics board because it's just not working. So there are many issues that are bothering the companies today. And so when I say that you have to take into account the ethical aspects, so what do I actually mean? So here we have some concerns, some concepts. Whoops, I think I missed few. Let's add them here as well. So altogether, we have found 96 different concerns. Here you have only 50 left. We took out the synonyms and those that are very close to each other. But these range from anything from safety concerns to existential concerns, normative issues, justice-related like legal issues, and of course the data ethics. So actually, it is quite difficult today to put this in practice. So we went a little bit further, not just guessing, but did a bit of research out there. We talked to 211 companies, and these companies came from US and Europe. And interestingly, what we find out that yes, it is a jungle out there, but the response trends were pretty much the same, regardless the company developed the AI or whether they actually used AI or were just dealing with pure software. So this means that the AI has not yet reached the discussion that takes place in public and academics has not, at least at that time, a couple of years ago, was not transferred to the practice. There were mixed maturity in how various ethical concerns were dealt with. Some companies were quite advanced, while others were basically not doing anything. And to our surprise, even 51% of the companies were confident that their system could not be misused. So this explains to us that that there is a need for something tangible out there. And now let's go fix the problem. First, this work stems back for many years. I've been in this field for some time, as I explained. And so how to fix any process problem in a company or how to bring new ideas. So this is a diagram or a picture that was published several years ago. And so what we need is we need conceptual tools, we need mental tools, and we need the operational tools. And when we put all those things together, we can talk about forming a high-performance culture and perhaps even prospering business, if you like. But the key issue here is that what does the AI ethics discussion or research today, where is it standing? So here's my problem. Current research that we find is mostly done by the philosophers and like-minded experts that are great producing new questions, new concepts, new ideas, which is needed, which is important, and also mental tools. And these are the principles. So many principles have been brought out. I would claim that about 95% of this research, however, doesn't translate to practice. What it does do is that it actually works in the education system behind on kind of understanding what are the high-level principles we should respect and confirm. But my focus has been on the quite practical viewpoint. So what are the methods, what are the tools, what are the techniques or practices that we can develop that is based on all that research, but doesn't overwhelm the company? So as a result of this work, this year we published a method that goes by name ECOLA. It is for ethically aligned AI development. And this is published in the Journal of Systems and Software this year, and it is an open access publication, so anybody can get the access. So how does ECOLA work? So when we look into it, it's a method for teams to do ethically aligned software AI development. So, and in practice, it is a card deck of 21 cards that covers 8 thematic areas. And those areas are analysis, data, transparency, human agency, security and safety, well-being, fairness, and accountability. And we suggest, and the research shows that it can be used by the development team. It's a tool for product owner, the one who decides, or is a principal agent when we decide what goes into system and what doesn't. Or even an external consultant can be used to, let's say, to indicate what are the requirements when we do a bid for that we would have AI ethics taken into account also in the bidding phase. We have proof tested this in academic and industrial context. Action research has been the method that we have used to develop this approach. And you can download your copy freely at the given address there. Each of the cards is divided in certain elements. So on the top, you see that there's the theme transparency, indicating this is card number 3, dealing with communication issue, and each card has the same outlook, different color, but that's, let's say, beside the point. So there's a motivation element, what to do element, and a practical example element. And so an important element, the AI ethics part, we have noticed is the motivation in terms of that we need to be able to also create awareness of the issues, how they are related to the system, and why should they be addressed. So then you have several things that can be asked. The developer can ask from themselves, or this can be brought into a discussion with the key stakeholders or the development team, or those people who have to say how things are done and what should be addressed, so we can do some prioritization. And here you can see some of the examples related to the actual communication perspective regarding feedback, understanding how what is the goal of the system, and if there is actually, if you are interacting with an AI, how is that brought to attention? What does it mean? All this discussion, all this documentation will, or the design will come out of from these discussions. Now, the research has shown that it's hard if something doesn't come tangibly there in the eyes of the developer, it actually ceases to exist fairly soon. So one of the most practical advice that we can give is that in order to make it visible, it has to be not causing trouble or not causing pain, but it has to be in the development desk, so to speak. So ethics in AI can be viewed as a non-functional requirement of an AI-based software system. And this is like our underlying argument. And the way it works in practice actually fairly straightforward. We have introduced this concept we call ethical requirement stack. So it starts from the business, it ends with the task. And on the left-hand side, you have all the, let's say, the ethical cards, the ECOLA cards, 21 of them. And then on the right-hand side, you have the ethical requirement stack. And specifically in the publication that we have below, we have focused on something that goes by name user story in software development. And there are other concepts as well, which are, let's say, features. A higher level concept, epic is yet another higher level concept. And at the lower level, from user story, some concrete tangible tasks can be drawn out. And if you look at the user story itself, it's a predefined, let's say, a practice, so that it has certain way of expressing what we want. So as a certain user, I want certain functionality so that I will be benefiting in a certain way. And the acceptance criteria is then also at the same time, when you come up with the user story, you also that can be turned as an acceptance criteria, given on how things begin, when certain things matter, and then you should be taking an action. And we have been now testing this in an autonomous maritime research project where we work with companies. And one of the use cases that we are actually now focusing on understanding how ECOLA can benefit the system design, we have now focused in the passenger flow concept. So even in the ships that carry cargo, there actually is some. It's also passengers are often involved. So we have taken the method, we have collected people, and then we have brought the stakeholders together. We prioritized the cards that should be talked about. And then, as a result of this work, the participants were making a lot of notes. So we had hundreds of notes, and on the left-hand side, you can see the authentic note regarding the discussion, certain issue on traceability. So the authentic node said XAI, so explainable AI. So we then turned that into a user story. As a system developer, I want to understand how the AI component works so that I can understand what causes the error in the system, etc. So you can see the example of here that how something that is mentioned or discussed, agreed somewhat, will actually then makes its way towards to be tangible component in the systems development project, or so that when it exists, it gets done, it can be tested, and that's what we are aiming for, making AI ethics tangible to the developers. So that and of course you have all the other viewpoints. You have perhaps the ethical aspects are brought in here. They can be in several places. So kind of demonstrating how this works in practice. So what I want to leave with you is that the key takeaways here is that there are the AI ethics concerns that are out there, and they need to be addressed by both the companies and public organizations. Organizations that use the AI solutions, they want to be, let's say, on the safe side, that somebody has thought about these important viewpoints. And there are a lot of stuff out there. These are what we call concepts, values, and principles. They remain today important, but they rarely help in practice, in practical development endeavors. Ecola, we suggest, is a method that empowers the developers and the stakeholders to do ethically aligned software and AI in design in practical settings. And this practice means that where AI ethics concerns are managed as non-functional software requirements. And the method itself is made available at the bit.ly/Ecola method. So please go download the paper from there, and you have the method cards attached to that paper. To this, I would like to conclude my presentation. I would be happy to take any questions, and you can reach me with my email address given there. Thank you so much.
Thank you very much, Pekka. That was a very interesting presentation. If anybody in the audience has a question, I would encourage to use Q&A. I see there is something in chat. Let me just see.
Thank you, Stephanie.
Wait, I just lost my Q&A, so I can't really.
Q&A doesn't have a question. Chat, Stephanie, thank the presentation.
Okay. Well, if there are no questions, I do have a couple of questions. The research in ethical AI, is this mainly the academic topic, or it's also done by industry? How would you say? Is it more research by academia or in industry?
Well, the developers, when we discuss with the developers what they do, how the ethical matters are dealt with. So the answer is that, well, they should be somehow dealt with, but it's not my responsibility. So that I think that somebody else is doing it. So there would be somebody or with the medical instrumentation that we have discussed with the AI developers that develop new ideas. They say, this is a prototype. So at the prototype level, we don't have to take this into account. But when it goes to real production, yes, we have to somehow manage it. And the problem with this kind of a discussion is that, who does it? How do they do it? What do they do? What is the agreement? And when we talk about the ethics, like the existential matters, often there is this argument made that, okay, the machine should decide who to kill. In this worst case scenario is that the car gets out of control, and then it is thrown into public. So it should decide somehow. That is completely a wrong discussion, and I don't think we should even. So my answer would be that we should make a car that doesn't fly to the audience and doesn't kill anybody. So it's that kind of a programming in that kind of intellect who decides cannot be done, and definitely should not be the developers at the end of the day. So it is an academic discussion because there are so few tools out there, and that is the problem. And this ECOLA is just one. Hopefully there are many others, and hopefully we start to see, how to make it, how to solve this or address the issue properly.
Yeah. Okay. That was actually my next question. It's and I guess ECOLA is one way towards that. Is there any kind of standardization? We like to test. We have the databases like MS Coco database where you can compare your algorithm. Is there an ethics AI database? I mean, I don't know if it's even possible to do that, but usually you find out the problem after it's already in public, right?
Well, I mean, my idea here is that, things get done when they become part of the regulation. So that as long as the field is, GDPR is a privacy issue matter thing, so all the European companies have to deal. I mean, anybody who does anything in Europe must deal with GDPR. So and that's part of the many things one should consider. But because it's there, companies have to answer provide an answer. So I think that is one way. But then again, I'm not so completely sure that because regulation should be kept to a certain level. You cannot regulate everything. So this is another worry that I have, and I'm not aware of all this kind of ethical database that would exist but perhaps again that is something that will come.
Okay, thank you. I guess there is nothing in Q&A yet. So I would like to thank you again. It was a very interesting talk.
Thank you, Miroslav.
Thank you very much, everyone. Thanks. Bye. So we have about 2-3 minutes left till we get the next speaker. I would use this time just to encourage audience, use the Q&A to ask questions even during the presentation so that I can gauge how much time I can let the speaker to talk. I don't have to cut him early. Okay, thank you very much, and we'll be back in about a couple of minutes. Welcome back. So our next speaker is Dr. Amanda Muller, and she is artificial intelligence system engineer and technical fellow for Northrop Grumman Mission Systems. Her talk will be on secure and ethical AI, framing the challenge for national security. Thank you, Amanda.
Thank you so much. As I said, my name is Dr. Amanda Muller. I'm a consulting artificial intelligence systems engineer at Northrop Grumman Corporation, located here in Arlington, Virginia, just outside of Washington, D.C. And my presentation today is on AI bias and how we can frame the challenge of AI bias for national security. I think this dovetails nicely with the last presentation and the discussion of AI ethics. So I'm hoping to have some conversation around that. At the end, I'll have about 5 minutes for questions. But first, I will give a little bit of background on bias in artificial intelligence and specifically how that relates to the national security domain. We'll talk about some specific strategies and governance around AI bias in national security and sum things up. And like I said, have some time for questions and discussion at the end, which I'm very much looking forward to. So first, let's talk about what bias is. I love this quote from Morgan Housel that says, your personal experiences make up maybe 0.0001% of what's happened in the world, but maybe 80% of how you think the world works. We are all biased toward our own personal history. And if we wanted to update that quote for artificial intelligence, we could say that the data that we feed into AI makes up maybe 0.001% of what's happened in the world, but 100% of how AI thinks the world works. So that necessarily biases our AI systems toward the data that's given to them. And bias is simply a disproportionate weight in favor of or against an idea or a thing. Doesn't necessarily have to be positive or negative, but in many cases it is interpreted in a negative consequence or a negative context. And it is necessarily part of artificial intelligence because we cannot possibly incorporate all of the data in the world, all of the context in the world into our AI systems and our data. Sometimes that is intentional. Sometimes we're purposely putting in particular types of data or biasing a system toward a particular use case. In other cases, it's unintentional, and we'll talk about both of those over the course of the presentation today. If you want to learn more about bias, a great place to start is this article that I have cited here. It identifies 23 different types of AI bias, and it's very easy to read, lays things out very clearly. I've got the word cloud over here on the right that's going to appear in my next couple of slides as well that identifies those 23 different types of AI bias. And this is just AI bias and data bias. This isn't all the other types of bias that exist out there in the world. So it just goes to show you how pervasive this challenge is in dealing with bias, in artificial intelligence. Bias also appears in the news. I'm going to give everybody about 10 seconds to read this XKCD cartoon. So this is funny. I really liked this cartoon. I loved XKCD anyway, but this cartoon just kind of demonstrates some of the perceptions that we have around artificial intelligence bias. But it also highlights a very important issue, which is that bias can have real consequences when it comes to making decisions that affect human beings. In this case, it's a hiring algorithm, and maybe this hiring algorithm has started to become sentient and incorporate its own biases, which is a fictional scenario. But when we do have bias in our systems, it can have very real consequences for the decisions that we make as a result of the data coming out of those algorithms. Other examples of bias in the news, there's a fantastic Netflix documentary called Coded Bias. It features the MIT Media Lab researcher, Dr. Joy Bolwini, and she is a doctor now. She just defended her dissertation a few weeks ago, which was after I submitted these slides, so apologies to Dr. Bolwini. Fantastic documentary, though, and it discusses the pervasiveness of AI in our society. And because AI is pervasive, because it touches everything that we do, when we have bias in those systems, it can have very real social consequences for the general population. And we've seen examples of this also in the news. In 2016, Microsoft's Twitter chatbot made headlines, and I'm sure everybody on this call has heard about this in some way, shape, or form. It's a chatbot that was put out onto Twitter, and within 24 hours started making very sexist and racist tweets, and it had to be taken down. It was amplifying the data that was fed into it, and that data was itself biased. And in some cases, this was adversarial in nature. There were people who were intentionally putting biased information into the chat that Tay was taking in. But it's just a demonstration of the very real consequences that can come about. AI's reputation took a huge hit after this incident. And then 5 years later, so just recently, you'd think that we would be paying attention to these things by now and making sure that they didn't happen. But Facebook made headlines. And for those of you who aren't on Facebook, first of all, great job. But second of all, Facebook does, if you watch a video, it makes recommendations for similar videos that you may want to watch. YouTube does the same thing. Have these algorithms that look at what's in the video and makes recommendations for similar videos. And this particular instance was a video featuring Black men, and Facebook prompted, keep seeing videos about primates. And that is absolutely unacceptable for many, many reasons. And it is absolutely astounding that 5 years after this Twitter chatbot debacle, that we still have such egregious instances of bias coming up in our AI algorithms in ways that are visible and that have real effects to the reputation of the companies that are putting these algorithms out. And this is all, it just goes to show that bias is pervasive. You have to continuously pay attention. You can't solve a problem once and think that it's solved forever. You have to continuously work to actively counteract bias. And this is very much true in the national security domain. And we can't talk about bias in national security without talking about deception. Deception has been part of warfare for as long as humans have been going to war, and unfortunately that's a very, very long time. Way back in 465 to 2000 BCE, no one's entirely sure when it was written, but Sun Tzu's Art of War specifically said all warfare is based on deception, and that remains true to this day. Getting an adversary to perceive something that isn't true offers an advantage because it injects signal, it masks signal, it makes them believe things that aren't necessarily true and can be used to mislead. We've seen examples of this in non-AI types of systems. When we put camouflage onto a military vehicle, we are deceiving the adversary into thinking that that vehicle isn't there. And then way back in Roman times, in Greek times, the Trojan horse was used to deceive an adversary and to get enemies behind a city's walls. So this has been going on for a very long time. It's just the nature of how we deceive is different today. And when we're using AI systems for national security, we can inject signal or bias into the data systems and into our algorithms as a way of achieving deception. So it is intentional in many cases, an adversarial tactic that can be used to fool AI systems. So for example, if we have an AI system that is using GPS data to do wayfinding for an aircraft, an adversary could potentially intercept the true GPS signal, spoof that signal, send it back to the AI algorithm that's doing its wayfinding, and send the aircraft to a completely different location. Now, if that aircraft is trying to save human life or potentially doing other things that could affect human life, and it's in the wrong location, you can imagine the types of consequences that would have. So we know this is happening. We know that adversaries are intercepting signals, they're spoofing signals, they're injecting bias into our data. And this is something that we actively have to work to counteract. Just like with the Twitter chatbot, we can't solve this problem once and think that it's solved forever. It requires an active real-time approach. I talked about the 23 different types of bias that exist in AI. We have many sources of bias in national security applications that hit many of those different types. Representation bias and sampling bias are pervasive, and in some cases, these are deliberate. So, we talked in the beginning about intentional bias versus unintentional bias. In some cases, we have intentional bias because there are other factors that are at play. So, for example, we know we have insufficient access to data when we're operating in a wartime environment. If we are in an adversarial environment, we can't go knocking on doors and say, hey, can you please share your data? It's not going to happen. We know we're not going to have access to particular types of data. But we also have institutional and bureaucratic stovepipes that we put up where different organizations don't necessarily share data with each other. And sometimes that's for very good reasons. We don't put classified information on unclassified systems. We necessarily keep that data separate. We have legally mandated data stovepipes where data doesn't get shared between organizations. And these are not things that we are going to be able to change, but they are things that we need to take into account, recognize that these are potential sources of bias, and actively work to mitigate the risks associated with that. We also have adversarially introduced bias like data set tampering. We know we have adversaries working to get access to our data sets, to change those data sets, potentially introduce false data, and also tamper with our algorithms, get access to the code, necessarily change the way that code is operating, and affect the outputs upon which decisions are being made. I love this example down at the bottom from an IEEE conference in 2018. It shows a kind of an accessible example of how easily an algorithm or a data set can be tampered with. This was an example of a self-driving car that was using some artificial intelligence to recognize a stop sign, which is important when you have a self-driving car that's operating out there on public roads. And they were very easily able to fool the algorithm into not recognizing that stop sign. And in some cases, it was in ways that the human eye wouldn't necessarily be able to detect. So this is just over here, the first image is simply some noise introduced into that image. Over here on the right, you have some kind of graffiti or art that's being put onto the stop signs. You see this out there in the world all the time. You wouldn't think twice about it. But this can very specifically be used to fool that algorithm into not recognizing that stop sign at all. So this is a very real example that can exist out there in the commercial space. And when we're talking about national security, absolutely everything we do has the potential for being attacked. So this chart just kind of shows some of the many vectors upon which our AI algorithms could potentially be attacked, and that bias could be introduced in the hardware, the software, the networks, and cyber attacks, and even things as far down the chain as AI trust attacks, where if we can get the operators who are making decisions based on the AI not to trust the AI, that in itself can disable the AI system. So we have to actively work to counteract all of this to ensure that our national security systems remain effective. So some of the challenges for counteracting bias, we have strategies to address these. And the first is bias testing. We have to test for bias all the time. And we're working with some small companies that are helping us to do this, to provide governance, to ensure that we're testing for bias among all the avenues that we know that bias can be injected. The challenges associated with that, I've touched on a few of these already, but known unknowns. We know there are things that are being held from us. In some cases, it's for very good reasons. In some cases, it's because we don't have access to the data, but we know that we don't know those things, and we have to take that into account and work to accept the risk or understand the risk associated with that. But we also have unknown unknowns. When we're operating in adversarial environments, particularly, we don't necessarily know the landscape that's on the other side of that line. So those can be a lot more difficult to counteract. But we can address those through bias testing, through audit, and through other means. And then we are operating in a dynamic environment. When we're talking about national security, our environment is constantly changing. There's an old saying that says, no plan survives first contact with the enemy. I don't think that's 100% true, but the sentiment is definitely there that everything changes and we have to constantly work to adapt and to counteract. The second strategy we have for counteracting bias is audit. And this is something that's used in the financial industry quite a bit. We need to use it within the national security domain as well to audit our systems to ensure that they are operating as intended within the context of the use cases in which we're operating them. The challenges associated with this is that we have a need for speed. It's not just a saying from Top Gun, it's absolutely true. We have to work quickly. And when we're in these dynamic mission environments, we have to adapt to change very quickly, and going back and auditing, taking things down, putting a pause on something so we can go back and audit it isn't necessarily in that right direction. So we have to strike that balance. The second challenge is satisfying disparate stakeholders. Operating in national security, we have a whole range of stakeholders, from the warfighter on the ground to the commander back at the base to the acquisition authority who acquired that system, essentially our customer, to the Congress who is allocating the funding for that system, to the American taxpayer who is paying for the funding for that system. And we really have to satisfy all of those. So again, it's striking that balance. It's being aware of what all of those different stakeholder needs are and making sure that we can adequately address all of those needs. And then finally, this was touched on in the last presentation as well. We need laws and regulatory guidance around the operation of artificial intelligence and how we deal with bias. The challenge here is that not everybody plays by the same rules. We can have our laws in this country, different countries have different laws. The more that we can work together to develop rules for the good of humanity, I think the better off we will be. And if we do have different sets of rules, that can potentially be used as a basis for adversarial attack. So if our particular laws and the constraints that we put on ourselves are publicly available and our adversaries have access to that, then they can potentially know how to exploit our systems. So it is important that we create those laws and regulation with a mind toward the fact that this could be used as a vector for attack. And I think it was also touched on in the last presentation that there is no one-size-fits-all solution. Laws for the financial industry and the automotive industry are not necessarily going to apply within the defense industry or for national security. So we absolutely need to ensure that the laws and the regulations that we create are specific to the use cases in which we're going to operate our AI systems. So I talked a little bit about how we can address these challenges, but more specifically, I think the most important thing is that we leverage best practices across government, academia, and industry. That's why I'm here today talking to you about this. My colleague Bruce Sweat is going to talk more about it tomorrow. But this is an all hands on deck type of situation. This isn't something that's going to be solved just by academia or just by government or just by industry. We all need to work together in order to address the challenges around AI bias. Also important is applying mission relevant knowledge. And I mean knowledge of how things are operated within the national security space. Having that knowledge allows us to account for the constraints that are unique to the mission space. So for example, we are typically operating at the tactical edge. Our hardware systems may be on the back of a Humvee. We don't have access to a data center with racks and racks of equipment. We have constraints around size, weight, and power. And those are things that people with mission relevant knowledge can bring to bear, can incorporate into the design and the operation of our AI systems. It also helps us reduce the number of unknown unknowns. So if we have additional knowledge of the mission space, people who have been on the ground, who understand how these things are being operated, it can help us to identify where our blind spots are and reduce that number of unknown unknowns. We also need national security specific laws and requirements. Again, this was touched on earlier, and I wrote down a quote from Pekka Abrahamsson that said, "You cannot regulate everything," which I absolutely agree with. We can't make these too specific. So we need things that are relevant to national security, but we need them to be general enough so that we can continue to innovate, we can continue to grow, we can continue to evolve, and that we don't set ourselves up for those laws to be a potential source of attack. And then finally, we need to maintain human responsibility for applications that have social and political ramifications or that require an understanding of context. Those are things that human beings are still better at than artificial intelligence is. Understanding the downstream social and political impacts of decisions, understanding the context of a situation, and what data was not provided to that algorithm that it might have an impact. But in doing that, in creating systems that adequately team humans and AI and allocate functions to the things that they are good at, we also need to remember that humans have their own biases. Remember that first quote that I said at the beginning of this presentation, that humans have bias in the information that they take in. And so we need to factor that in as we design systems that adequately team humans and AI together. So in summary, bias is a real and ongoing challenge in all AI applications, but it's particularly important, and I'm biased, I admit this, toward national security. But I think it's true that we have all of the challenges that commercial world has, and we have the increased risk of adversarially introduced bias among all those different attack vectors that I talked about. So this is a challenge that's going to require that we continue to pay attention to it, that we continue to work to counter bias, to understand the risks associated with the biases that we can't counter. So this is an area that is ripe for future research and study. I hope that you agree with me and that all the representatives of industry, academia, and government on this call will help to take up that challenge. So thank you very much. With that, I will open the floor to questions.
Thank you, Amanda. It was a very, very interesting presentation, very enjoyable. I would, yes, like to ask audience if there is any question. It's a good time to ask now. If there are no questions, then I'll have one. You mentioned that this bias research and say, containment is not one and done thing, that it has to be done on a continuous basis. Like that, how is it done? Does it require human intervention on a continuous basis, or yet hopefully it can be automated?
Yeah, absolutely. I think it needs to be part of our DevSecOps processes. And you know, I talked about the need for speed. Yeah, we can't like put a system into operations and then say, okay, now we need to come back and test it again and bring it offline and then bring it back up. It has to be continuous. I think there is a need for, I hate the term human in the loop, but I have yet to come up with a better one. So I'm going to say human in the loop for some types of testing for bias, but we need to have it be automated and continuous in order to meet the needs of our operational environments. So I think it's a combination of both. But we absolutely need that automated and continuous testing.
Yes, because if you think of scaling, it's going to be hard keeping.
Yep, absolutely.
Because this Facebook example, actually, I think Google had something similar several years ago, and I'm just perplexed how could it happen again. Do you think that could have been automated somehow, or they completely really required human?
Yeah. I have to imagine, and I don't know, so I probably shouldn't get myself into trouble by trying to answer a question that I don't know the answer to. But I think it just demonstrates that it's because no company wants that kind of damage to their reputation. So I have to imagine that it was some kind of oversight, but it's one that we have to continuously pay attention to, because this just demonstrates that these types of bias can creep into the systems if we're not paying attention.
Okay, well, thank you very much again.
Thank you.
And if there are no questions, and it seems there aren't, it was very clear, I guess. Then I guess we can go to the next speaker. And our next speaker is coming from IBM. It's Achille Fokoue. I hope I pronounced it properly. Achille is Distinguished Research Scientist and Master Innovator at IBM Research. And the title of his presentation is Answering Questions Using Neuro-Symbolic AI. Definitely sounds interesting. Achille, please take the floor.
So I'm Achille Fokoue. I'm a research scientist at IBM Research, where I lead the Foundation of AI Reasoning Group. Today, I will talk about some of our research that leverage neuro-symbolic AI to help answer questions over structured and unstructured data and gain insight from the data. Next, please. So organizations and individuals alike are faced with an increased volume, velocity, and variety of the data. They often struggle to answer basic questions about the data and gain insight from it. Given enough training data and supervision, traditional deep learning can help address this problem. Unfortunately, large training data set can be expensive and in many domains, and many stakeholders lack the deep technical skills to interact and query the data using structural languages like like SQL or Sparkle. Next. A key question, thank you very much. A key question is then, how can we gain insight and answer questions over the growing volume of complex data with limited technical expertise and limited supervision? In this talk, I will argue that a neuro-symbolic AI approach that combines traditional deep learning and symbolic reasoning can help with limited supervision, can help learn with limited supervision how to answer questions about what is explicitly in the data, what is implied by the data, and what is missing from the data. Next, please. So in this presentation, I will describe 4 core research themes that leverage neuro-symbolic AI to address some of the core challenges discussed earlier. First, I will present our ongoing research on learning with limited supervision, how to answer natural language questions over large knowledge bases, for example, in the form of knowledge graph or a database. Unfortunately, not all companies have the key information in knowledge bases. Instead, that information is often present in unstructured data, such as text documents. Hence, the importance of knowledge acquisition. Here, the goal is to acquire from unstructured documents knowledge about key entities in a particular domain and relation between those entities and key events involving those entities. Third, from the knowledge acquisition, from the knowledge acquired and stored in the knowledge base, our research also aims to learn the patterns of recurring key events in a particular domain. Those patterns called schema capture the structure of essential elements of a complex event type. For example, in the intelligence domain, a schema for a terrorist attack would consist of a radicalization phase, a training phase, a planning phase, an execution phase, and finally a prosecution phase. Each phase is itself another complex event. Finally, from a library of learned schema, when presented with a new situation described in a structure or instruction form, our research aimed at recognizing which schema is being instantiated. This enables us to understand the broader context in which the current situation occurs, and more importantly, enable us to predict and answer questions about what to expect next. Next, please. Next page, please. Okay, now let's move to knowledge-based question answering. Next. Okay, so question answering has been a popular task to assess research progress in natural language understanding. Let's illustrate the current state of the art on a simple example. Next. So, given the question, where was Michael Jordan born? Existing question answering system can retrieve relevant text from Wikipedia and show us the answer span. Here, New York City, Brooklyn. This typically requires hundreds of thousands of such question answer pairs for deep learning based system to learn. Basically, deep learning model can perform sophisticated pattern recognition given a specific task such as simple question answering. Next. However, if we slightly change the question to which country was Michael Jordan born in, those systems fail because these require multiple step reasoning. Next. Next. Yeah. As a human, we can reason that New York City is in the United States, and the United States is a country where, hence, we can conclude that Michael Jordan was indeed born in the United States. Such reasoning is relatively trivial for humans, but machines still struggle. Next. Next. On the other hand, some systems have tried to train a task-specific reasoning system, but it requires a significant human annotation. Next page, please. So, knowledge-based question answering, or KBQA. Next. So, given the Michael Jordan question, the task is to transform the natural language question into a query language. This is an intermediary structural representation which requires reasoning to retrieve the answer from the knowledge base. Next. End-to-end deep learning systems do not perform well on this task because of the reasoning need and the lack of large-scale training data. Next. Going back to the previous Michael Jordan example, on the one hand, we can derive that the question that we have, have an answer, require an answer to be a country. Next. On the other hand, the knowledge base provides only the place of birth as a city. The required reasoning is detecting that granularity mismatch between the query, the question that asks for a country, and the information in the KB, which is provided as a city. Next. Next. So we need to get more information from the KB to solve that mismatch in granularity, and then perform transitive reasoning on properties like birthplace and part of, in this example, to infer that Michael Jordan is also born in the United States. Next. So the transitive reasoning involved here is based on the fact that if a person is born in a city, then they're also born in all the places that contain that city, for example, the state, the country, or the continent. Next. Yes. So next. So very good. So this KBQA task has a lot of real-world application, specifically in enterprise setting, such as natural language interface for databases or conversational systems. Next page, please. So this slide is a bit technical, so forgive me to go in a bit more technical detail, but I need that level of detail to introduce and explain the value of two key components of this approach. Our newest symbolic approach to knowledge-based question answering is twofold. Next. So first, in order for machines to have the ability to reason, we need natural language to be represented in a form that facilitates reasoning. In the first step of our approach, we semantically parse a natural language question to an ambiguous and generic representation called abstract meaning representation, or AMR for short. Here we can see that two semantically equivalent variants of the same question, are parsed to the same AMR representation. The two variants here are which country was Michael Jordan born in, and which country is the birthplace of Michael Jordan. This makes our approach more robust to different ways in which the same concept can be expressed in natural language. Next. Second, the second important step here, in that step, we use our first of its kind neuro-symbolic reasoner called logical neural networks, or LNN, to perform reasoning over the knowledge base to get a final answer. LNN is a new framework that seamlessly provides key properties of both neural nets and symbolic logic. It can learn complex patterns from data and can also perform symbolic reasoning. Next page, please. So as of last week, so what I'm going to say now is actually true as of last week. So I should have written that in the past tense because NSQA system that we have been developing in my team for the past year and a half, 2 years has been the state of the art in KBQA up to last week. So these results are actually true up to last week. So as of last week, our neuro-symbolic approach outperformed a state-of-the-art system in two important knowledge-based question answering tasks, QALD and LC-QUAD. Of particular interest is that those two data sets provide limited training data. This is particularly true for QALD, which has only about 400 training questions. As mentioned earlier, typical end-to-end pure neural network approaches require hundreds of thousands of training question-answer pairs. As a result, those deep learning-based systems perform poorly on those two data sets and are not even among the top systems. So I think so can you go to the next page, please? Okay, so last week I attended International Semantic Web Conference where a new system was presented called EdQA. So this system reached the same performance as our system on QALD, but it outperformed our system by about a 9 percentage point on LC-QUAD. What is interesting here is that this system is not a pure end-to-end. It's not a pure end-to-end deep learning system. It's actually closer to a neuro-symbolic approach as our system because it really combines, on the one hand, deep learning. It uses a model like BERT for some aspect of the system, but it combines it with symbolic rules to really facilitate the deep understanding of the question and being able to answer the question over the knowledge base. So next. So let's move to knowledge acquisition. So now we do not always have information in a well-maintained knowledge base. Often key information is present in unstructured sources. Knowledge acquisition is critical to extract key entities, primitive events, and relations. In the example here on the right, juvenile charged with bringing bomb to school, we use our multilingual event and entity recognition models to detect the key entities in bold, namely juvenile, bomb, school, and we also detect anchor words for key events in color, here, charge, and bringing. Next. So we also identify the type, here, person, weapons, organization for entities, and indictment and transportation for the events. Next. Next. Furthermore, we identify the connection between events and the entity involved in them. For example, the agent of transportation event is the juvenile, and the artifact being transported is the bomb. Next. Next. So finally, we also need to to understand the temporal dynamics and between the event and causality. We extract temporal and causal relation between events. Next, actually, staying on that page, please. So two approaches are really key to get this result. First, we use information extraction against a predefined vocabulary, which provides great precision. However, it requires specific training on the vocabulary. Alternatively, we can leverage, as in our knowledge-based question answering, semantic parsing to AMR that is exhaustively trained once on a large corpus. Think of hundreds of thousands of examples, and needs only limited fine-tuning on a particular domain with just few hundred examples. Next. Yes. So now, individual primitive events do not happen in a vacuum. They typically are part of a larger, complex event. In our previous example, the primitive event transportation of a bomb to school and indictment are part of the complex event, a failed terrorist attack, which will typically start with a radicalization phase. Next. In our example, there was prior evidence of radicalization. Next. Examples of complex events include a terrorist attack, an IT security incident, a customer complaint, or even just eating at a restaurant. Next. So let's move to schema instantiation and predictions. Next. So as human, if we observe enough instances of a particular type of complex event, for example, many instances of eating at a restaurant, we can quickly recognize that there is a certain pattern, there's a certain recurring structure or pattern to that type of complex event. This recurring structure or pattern is what we call a complex event schema, or simply a schema. A schema captures information about the type of participants and their role. For example, customers, cashier, food, cash. It also captures the key step or phases or sub-events. For example, eating at a restaurant consists of arriving at the restaurant, placing an order, eating, and finally paying. Finally, a schema also captures a typical duration. For example, paying the bill at the end typically takes less time than eating. Next, please. The schemas have three key features. First, they are hierarchical. They provide different levels of specificity. For example, eating at a fine dining restaurant schema is a more specific version of the eating at a restaurant schema. They are compositional. Schema can be composed of other schema. For example, simply getting to the restaurant could be expanded into another complex event schema. Finally, and more importantly, schemas are human readable. They can be inspected by human to provide a level of explanation when we use a schema to make prediction, and we'll talk about that later. This is a very important difference compared to the kind of latent and hard to inspect abstraction from pure deep learning models. Next. So schema can serve as tool for inference and prediction. We have developed techniques that, given partial observation, can figure out which schema from a collection of schemas best matches or explains the current unfolding situation or scenario. This is the schema instantiation or schema matching problem. Once we have identified the most likely active schema, we can ask and answer the following key questions. What is more likely to happen next? Who or what else may be involved? When will the event be completed? What unobserved events may have already occurred? Next. So because I just have 2 minutes left, I'm going to keep the detail of this slide. I'm just going to point out that we have developed a pipeline to learn to extract complex event schema from multimedia documents. And this pipeline has been used as part of a DARPA project, a DARPA-funded project. So let's move to the next slides so that we have time for questions, conclusion. Thank you. So to conclude, in this talk, I have described how a neurosymbolic AI approach based on semantic parsing, probabilistic reasoning using novel logical neural nets, schema-based inference, enabled with limited supervision, natural language question over structured knowledge graphs, knowledge acquisition from unstructured data, and schema induction and schema-based predictions. Thank you. Next. Thank you. Any questions?
Thank you very much. It was yet another interesting talk, and just want to see if there are any questions. Seems that there are no questions from the audience. So I'm not in NLP, so forgive me if my questions are a bit naive. When we are doing computer vision, typically we have like thousands or tens of thousands of images to train. And I saw that in one example, you have like about 150 training samples, and these seem like complex models. So how is it possible to train with such limited number of samples?
So that precisely the motivation of our approach, right? Is that, if you think about that, yes, I mean, there are models that have been trained on really large corpus, right? But these are general domain corpus, right? If you work in aviation, right, you actually want a model that is trained on that understand your document, your manual, right? And if you work in a different industry, right, you also have your own knowledge base with its own peculiarity, and that knowledge base structure is very different from what is publicly available, right? So you do not really care about answering question over Wikipedia, right? You care about answering question over knowledge, information in your knowledge base, right? So in that setting, we don't have enough information. That's
okay. So it's basically applied in a limited ecosystem, so to speak.
Exactly. That's the motivation here, is that in those settings, we don't have enough training data. And our approach actually does not require to train the whole system end to end with a lot of data. We have components that do well what they've been trained for, and those components can be trained for in a general setting and just fine tune with a smaller number of examples. So, and I think that's the key of our approach, is that to get to that level of reasoning, we do not actually require that huge amount of supervision. And that's really why we actually presented results on this data set with very limited training data, because this is really what makes this problem challenging. And it's a real problem. It's not an academic exercise. I mean,
yes. No, see, this is a real problem. Is everything left to like deep learning, or you have some pre-existing knowledge? I mean, you mentioned actually, you kind of answered.
Yes,
rigging, you know that this is transportation, right?
Yes.
So there is some knowledge built into your system, and then you're training.
Yeah, exactly. I think what we're trying to do is really get the best of both worlds, right? We're not saying that deep learning is not good. I mean, it's great, right? But we need to complement it with the knowledge that we have, right, in a specific domain, and also use kind of old-fashioned techniques like traditional reasoning that can actually help us provide explanation. This is another important aspect, is that in those in domains that we care about, or our customer care about, it's not good enough to just have the answer, right? You really want to understand how the system derived that answer. So that's why we use things like logical neural network, because yes, they use a neural network, but in a way where you can inspect the neural network and you can provide a logical explanation to what is going on in the neural network. Likewise, we use things like schemas because they have a structure that is human readable and explainable, right? So this is really what we're trying to do. We're trying to, yes, leverage deep learning where we can, but also try to use a symbolic approach to, address some of its limitation in terms of, data, huge data needs and lack of explanation.
Mm-hmm. Yeah, yes. I think in industry, there is this combination, hybrid approach of
yes,
knowledge
exactly.
plus the AI for something which is hard to explain. Well, thank you very much. It was a very interesting talk, and I would like to thank all the speakers. And I think there are actually 2 questions, so let me give them a chance. The first is, will your approach work for English language, or it can be applied to other natural languages as well?
It's not specific to English. It can be applied to other languages. As a matter of fact, as I mentioned, we actually use our multilingual models, and we actually test it. So individual components have been tested with multiple languages, but the whole pipeline itself has been tested already with English and Spanish. But in principle, other languages should also work through the whole pipeline. So it's not specific to English.
And there is another, actually, I think, very interesting question. Could this enable predictive clinical trials protocols? For example, the ability to assess past and current protocols to help predict additional opportunities?
So we have not, I think that's a very good question, right? We haven't looked particularly at, clinical trial use case. It's a very important use case. Many years ago, I worked on, applying some level of reasoning to help, in clinical trial, registration. But I think this approach could be helpful, but frankly, we haven't thought deeply about that.
Mm-hmm. Okay, thank you very much. So once again, I'd like to thank all the speakers, and the next session will start at 11:55.